Welcome to Ray Shikshan Samstha Satara Rose Project Standard 11th Science Stream conducted by Yeshwantrao Chavan Institute of Science Satara. Now, in today's lecture, we study about the electric current through the conductor. The weightage of this chapter is near about 4 marks, and it is the most important chapter for 12th and basic of the electric current. In this chapter, we study about the electric current and its some applications. Now, in this chapter, electric current is the main concept. Here, the electric current means a rate of flow of charges inside the conductor. It is called as the electric current. The definition is such that the flow of charges across the cross-sectional area of the conductor is called as the electric current. Equation is written as I is equal to Q upon T. Here I is the current which are flowing through the conductor, and Q means the charges flowing through that conductor in a time T. So the Q upon T, it is called the electric current. This electric current is measured in ampere. So assign it is ampere. Mainly in physics laboratory, we use a micrometer, millimeter for measuring the current. This ampere is a large unit of current. Now, a question is asked such that define ampere or define 1 ampere. This question carry 1 marks. When 1 coulomb charge will be flowed through the conductor in 1 second, then that current is said to be 1 ampere. So 1 coulomb charges are flowing in 1 second in the wire or in the conductor. So this is called as the 1 ampere current. आता यामध्ये थोडंसं मी आता मराठीमध्ये थोडंसं बोलणार आहे. ही एक वायर आहे, कॉपरची वायर आहे, तुम्हाला माहिती आहे. आपण ज्यावेळेस ही अशी एक वायर असते, यामध्ये कॉपर आहे सगळं इथं, तुमच्या हे कॉपर आहे. ही वायर आपण ज्यावेळेस जोडतो बॅटरीला, म्हणजे समजा ही बॅटरी असेल, असे हे सेल तुम्हाला माहिती, हे वायर्स आहेत त्याला जोडलेले. तर या बॅटरीमधून जे काही चार्जेस फ्लो होतात आणि या वायरमधून जे फ्लो होतात त्याला आपण इलेक्ट्रॉन्स मूव्ह होतात असं म्हणतो या वायरमधून, अशा आहे म्हणून. तर या वायरमधून किती इलेक्ट्रॉन्स फ्लो झालेले आहेत ते मेजर करण्याचं जे युनिट आहे त्याला आपण थोडक्यात इथं एम्पियर असं म्हणतो. सो मेनली दिस एम्पियर इज अ मेजर of flow of electrons mainly. Now, this when we apply voltage using this battery, and some load resistance is connected to this battery using the wire. So this is a LED with load resistance. When this is connected, this V means potential difference applied across the battery or cell, and I is the current flowing through this wire. Then George Ohm in 1828 discovered a law that is called as Ohm's law, and this is a very simple law, and in exam a statement is important. A law of physical state means this wire is supposed to be material which are used for this wire, means in this wire copper is used. Its dimensions means area of cross section, its length, etc., and temperature, surrounding temperature of this wire. Mainly these three material dimension and temperature are the same or constant. Then electric current means charges which are flowing to this wire is directly proportional to the potential difference applied across the conductor of wire, and this potential difference is applied by the cell battery. So it is a simple statement or simple law. Now this law is written as in this form: I is direct proportional to V, also V is direct proportional to I. Mainly the second this equation is used, V is direct proportional to I. Here V is the potential difference applied across the resistor, applied across the conductor, and I is the current flowing through that conductor. So when we want to neglect this proportionality sign, so we get a constant of proportionality. It is called as the R, capital R. So mainly equation V is equal to R into I, and here R is called as the resistance of that wire. तर थोडक्यात यामध्ये आपण ज्यावेळेस ह्या बॅटरी घेतो आणि वायर यामध्ये आहेत काय, आणि आपण याला काहीतरी जोडतो, बल्ब असेल, एलईडी असेल, काय असेल, त्यावेळेस तो एलईडी ग्लो होतो. तर ह्या वायर मधून जो काही इलेक्ट्रॉन्स मूव्ह होणार आहेत किंवा फ्लो होणार आहेत, त्याला जे वायर मध्ये थोडस अपोजिशन होतं, त्याला म्हणतो आपण थोडक्यात रेजिस्टन्स. अपोजिशन म्हणजे जसं नदीमधून पाणी वाहत असतं, त्यामध्ये काही दगड असतात, काही त्यामध्ये झाड असतात, काही लहान लहान छोटी, तर त्यामध्ये जो पाणी फ्लो होण्यासाठी जसा विरोध निर्माण होतो तिथं, तसंच ह्या वायर मध्ये सुद्धा इलेक्ट्रॉन्स ज्यावेळेस मूव्ह होतात त्यावेळेला आत ऍटम असतात, ते त्याला अपोज करतात, त्याला आपण रेजिस्टन्स असं म्हणतो. तर मेनली resistance means the opposition of the flow of electric charges through the conductor. It is called as the resistance. यामध्ये प्रत्येक वायरचा रेजिस्टन्स म्हणजे प्रत्येक मटेरियल आपण यूज करतो, कॉपर, सिल्वर, गोल्ड, etc. These are the different materials which are used for the conducting, and resistance of that different materials or different metals are different, and it is written as R is equal to V upon I. Here R means resistance, V upon I. Here V is the potential difference and I is the current. Mainly when we plot a graph, I versus V means we plot a potential on x-axis and current, measuring current on the y-axis. Then this graph shows a straight line in which is passing through origin O. तर हा ग्राफ आपल्याला काय सांगतो थोडक्यात, तर हा ग्राफ आहे तो स्ट्रेट लाईन आहे. म्हणजे जसं जसं तुम्ही व्होल्टेज वाढवाल ह्या एखाद्या लोड रेजिस्टन्सवर किंवा लोडवर, त्यामध्ये तो करंट त्यामध्ये वाढत जातो त्या वायर, म्हणजे व्होल्टेज वाढलं की करंट वाढतो. हा लिनियर ग्राफ आहे, दिसतो तुम्ही. आणि त्याला ओहम्स लॉ जे आहेत तिथं आपण अप्लाय होतो बरोबर, कारण व्ही इज डायरेक्ट प्रोपोर्शनल टू आय असं आपण म्हणतोय. म्हणजे व्ही वाढला तर आय वाढणार आहे, व्ही कमी झाला तर आय सुद्धा कमी होणार आहे. सो व्ही इज डायरेक्ट प्रोपोर्शनल टू आय. When we calculate the graph of this straight line, then we obtain a slope, and we take slope, and we calculate the resistance R. It is equal to 1 upon slope, means inverse of this slope. So using this IV characteristic of a conductor, we calculate the slope, and using this slope we calculate the resistance of that wire. Symbol is a very simple, which is on the screen. एक सिंबल लहानसा आहे. आपण जिथं जिथं आपण रेजिस्टन्स वापरतो सर्किट मध्ये, तर त्याचा हा सिंबल आहे. resistance symbol. SI unit of this resistance is ohm, and this ohm is give name honors with George ओमच्या ओम सायंटिस्टने याचा शोध लावलाय म्हणून त्याच्या रेजिस्टन्सला जे युनिट दिलेलं आहे ते ओमच्या नावाने दिलेलं आहे. So 1 ohm is equal to 1 volt divided by 1 ohm. It means 1 volt which are applied across the conductor, and 1 ampere is current flowing through that conductor. Then we'll state that the resistance of that wire is supposed to be 1 ohm. तर हा रेजिस्टन्स आहे R, त्याचा सिम्बॉल आहे. आपण सर्किट डायग्राम ज्यावेळेस वेगवेगळ्या ड्रॉ करतो त्यावेळेस आपण हा सिम्बॉल आपण इथं वापरतो. आणि 1 ओहमची डेफिनेशन इथं आपल्याला एक नवीन एक तयार झाली दिसते तुम्हाला, ओहम किंवा 1 ओहम म्हणूया आपण त्याला. सो 1 ओहम इज इक्वल टू when we apply a 1 volt potential difference across the conductor passes a current of 1 ampere, then that wire is said to be 1 ohm resistance. इथं 1 ओहमची डेफिनेशन तयार होते. मग असे तुम्हाला सांगितले की रेजिस्टन्स मीन्स द position of a flow of electrons. Now we consider copper. Then how much free electrons are in the copper? So it is equal to 10 raised to 22 electrons per cubic centimeter. म्हणजे 1 सेंटीमीटर लांब, 1 सेंटीमीटर रुंद आणि 1 सेंटीमीटर उंच असा एक ब्लॉक आपण जर घेतला कॉपरचा, तर त्यामध्ये 10 raised to 22 एवढे इतके मोठे इलेक्ट्रॉन्स, इतके नंबर ऑफ इलेक्ट्रॉन्स त्यामध्ये प्रेझेंट असतात, फ्री इलेक्ट्रॉन्स असेल. And these at room temperature, what happened here? When we cannot apply external potential difference across that wire, then electrons are in random motion. Means we consider this wire. So some electrons are traveling at right side and some electrons are traveling at left side. Random motion means when we suppose 100 electrons which is traveling at right side, then at that time also 100 electrons are traveling at left hand side. It is a very simple number, but it is a very large electrons. Practically very large. We consider only 100 here. Means net flow of electrons inside the wire is 0, because 100 electrons supposed to be traveling at right side. Then 100 electrons will be traveling at left side. So net flow of current here is 0. So there is no potential difference applied across the wire. Then electrons are in a random motion, and directions of that electrons are not same. So net electric current through that wire will be 0. Means when we आपण जर ह्या वायरला हात लावला तर शॉक बसत नाही त्या वायर मध्ये. तुम्ही बघितले की आपण पोटेन्शियल डिफरन्स कुठला दिलेला नाही वायरला, असा ही वायर आहे. काय शॉक बसत नाही तर याला ह्यामध्ये जे इलेक्ट्रॉन्स रॅन्डमली मूव्ह होत आहेत आतमध्ये, त्यांना एक डेफिनाइट डायरेक्शन नाहीये. ते कुठेही कसेही मूव्ह होतात, इकडे तिकडे सारखे रॅन्डमली मूव्ह होत असतात. नेट त्यांना डायरेक्शन नाहीये इलेक्ट्रॉन्स ह्या मेटलमधून वाहतात त्यावेळेस. आता when we apply potential difference, then what happen? A negatively charged electron is attracted towards the positive plate or positive terminal of the battery, and due to this electrons get a net direction which are flowing through the wire, and that is said to be current which are set up in the wire, or this causes electric current to the flow to the conductor. That is the direction of electric field. म्हणजे आपण ज्यावेळेला ही बॅटरी अशी घेतो इथं आणि बॅटरी घेतल्यानंतर आपण यावेळेस आपण एलईडी वगैरे यामध्ये लावतो किंवा काहीतरी लावतो, त्यावेळेला पोटेन्शियल डिफरन्स आपण या वायर मध्ये अप्लाय करतो. आणि यामध्ये जे इलेक्ट्रॉनची डायरेक्शन असते यामध्ये फ्लो होण्याची, ती नेट डायरेक्शन मिळते आपल्याला. म्हणजे निगेटिव्ह टर्मिनल पासून इलेक्ट्रॉन्स निघतात ऍक्च्युअली आणि ते पॉझिटिव्ह टर्मिनलकडे जातात. म्हणजे एक ठराविक डायरेक्शन त्याला मिळते आणि त्यामध्ये आपल्याला इलेक्ट्रिक करंट फ्लो झालेलं दिसतं. Now at room temperature, what happens? At room temperature, atoms which are present inside the conductor are in a vibrating state. Means these atoms means nucleus, and in that nucleus some protons, neutrons are in the nucleus. So these atoms and electrons are revolving around that nucleus. These are in the vibration. Means they are in a vibrating state. It is not stable. It is vibrates. We know that when temperature increases, the vibration of the electron is also increases. So when these atoms will be vibrates, then these free electrons are collide on that atom, and these atoms produce resistance to flow of the electrons inside the wire. So this is the resistance which has increased in terms of temperature. Means when we increase the temperature of the wire or conductor, then the resistance of that wire is increased high, because vibrations of the atom is increased, and due to these vibrations, collision of the electrons on the atom will be also increased. When collision is increases, then electrons which are traveling in one direction is stopped by atoms. Then that is called as the opposition. So the mainly increase the temperature, increase the resistance. म्हणजे ज्यावेळेस आपण एखादी वायर गरम करतो, त्यावेळेस त्यामध्ये किंवा थर्मली आपण त्याला जर काय दिली हीट वगैरे, तर ती वायर मधला जो रेजिस्टन्स आहे तो वाढतो. कारण इलेक्ट्रॉन जे मूव्ह होणार आहे त्या वायर मध्ये, त्याचं कोलाइड होण्याचा जो रेट आहे तो वाढतो. आता ह्यामध्ये ड्रिफ्ट व्हेलॉसिटी हा एक महत्वाचा कन्सेप्ट आहे. ड्रिफ्ट व्हेलॉसिटी means a very important concept here, and in exam ask questions such as that. Define a drift velocity. Drift velocity means it is a constant velocity of electron when we apply electric field. That is called the drift velocity. Constant velocity means electrons are incident on different atoms and accelerate towards the positive terminal. Then there is some constant velocity of all electrons, and that is called as the drift velocity. Now, drift velocity means here in a metallic conductor at room temperature, electrons are in a state of random motion, which are we know that, and frequently it collides on different atoms. But its velocity of that free electrons is near about 10 raised to 5 meters per second. It is a large velocity, but it is not constant velocity. It is a velocity between two successive collision of the electron of different atoms. And due to this random motion, net velocity opposite to the field direction is zero. Now, when we apply potential difference across the conductor, then what happens? Electrons gain velocity and is accelerated towards the positive terminal, and the direction of these electrons will be opposite to the electric field. We know that. So, as a result, the electrons are drift with a certain velocity or certain constant velocity opposite to the field, which is called as drift velocity. And this drift velocity of a copper is near about 10 raised to minus 3 meters per second. It is a small velocity, 10 raised to minus 3 meters per second. And this drift velocity of electrons produce a current. Mainly, drift velocity is responsible for flow of current through the conductor. So, when electrons are larger, then drift velocity will decreases, and due to this drift velocity decreases, magnitude of current will be at that time will be large. Now there are some limitations of this Ohm's law. म्हणजे आपल्याला हा Ohm's law सगळीकडे काही उपयोगी, म्हणजे त्याला काही लिमिटेशन्स आहेत. म्हणजे काही म्हणजे हाय टेम्परेचरला हा जो नियम आहे Ohm's lawचा तो ओबे होत नाही. म्हणजे when good conductors are, when we increase the current, then temperature of that conductor will be also increases, and due to this increase in temperature, the vibrations of the atoms is also increases, and vibrations are increases. We know that the resistance of the wire is also increases. So this is the limitations. Means at higher temperature, this Ohm's law is not obey. We plot here I versus V, means current on the y-axis and voltage applied on the x-axis. Then at end point, this cursor will be at this point. This cursor will be show this straight line is not obey. This material, which are called as non-ohmic materials in this reason. So this is the first limitation, and second limitation for the semiconductors. Semiconductors means it is not a conductor, mainly pure conductor or not insulator. It is the intermediate state between conductor and semiconductor. Semiconductor and conductor. So this LED is used, means silicon germanium is used in this PN junction. This is LED. In this LED, we use a semiconductor. Now this is the IV characteristic of the semiconductor. We clearly seen that here. When we increase the temperature, when we increase the voltage, then there is no change in the current which are flowing to the semiconductor. But at a certain stage is appear here, suddenly a current is increases inside the semiconductor, and this experiment is it dwells under the IV characteristic of semiconductor. So resistance of this semiconductor material will be vary with the current and the polarity of potential. See it. Now, question is asking on the exam such that are the limitations of Ohm's law. Weightage of this question is near about 2 marks. Now, a specific resistance means we know that the specific resistance of the material or any conductor, it is a specific resistance, means resistance of that wire is direct proportional to length. Means length is increases, resistance of wire is also increase. And when we increase the area of cross section, then the resistance of that wire will be decreases. म्हणजे तुम्हाला आता इथं थोडक्यात दाखवतो की आपण जी वायर घेतो इथं चार्ज फ्लो करण्यासाठी किंवा करंट फ्लो करण्यासाठी ह्याची जर लेंथ वाढत गेली तर ह्याचा रेजिस्टन्स पण वाढणार, लेंथ वाढत जाईल तशी. आणि ह्याचा एरिया क्रॉस सेक्शन म्हणजे हा जो एरिया क्रॉस सेक्शन असतो आपण दिसतोय म्हणजे थोडक्यात ह्या वायरची जाडी, ही वायरची जाडी वाढत गेली अशी मोठी मोठी वायर होत गेली तर त्याचा रेजिस्टन्स कमी होत जातो. So R is directly proportional to L and inversely proportional to A. Here L means length and A means area cross section. When we want to neglect this proportionality sign, so we get a constant of proportionality. It is called as the rho. हा आडवा पिन नाही, हा रो आहे actually. लॉग टेबल मध्ये याचे जे प्रोनाउन्सिएशन आहे ते दिलेले आहे. So R is equal to rho L upon capital A. Here this rho is called as the specific resistance because this resistance is depend on the length, also area and resistance of that wire. Now this rho is equal to Ra upon L. Means we know that this rho is proportionally constant and that is called as specific resistance of that conductor or that material. So this rho is called as specific resistance. So we know about that resistance is measured in ohm. This ohm area cross section is measured in meter square or centimeter square, and L means length of that which is measured in meter. So when area cross section will be 1 unit and length of the wire is supposed to be 1 unit, then specific resistance of that wire will be equal to resistance of that wire. So this is called as the specific resistance is equal to resistance of that wire. Now what is the definition of the specific resistance? The resistance of a wire of a unit length and unit of cross-sectional area is called as a specific resistance. So here the resistance of a wire of a unit length and unit of cross-sectional area is called as the specific resistance. The unit of this specific resistance is ohm meter. And when we take a reciprocal of this specific resistance, then it is called as the conductivity. And it is denoted by sigma here, sigma. So the reciprocal of the resistivity is resistivity or specific resistance. It is called as the conductivity of the material. And the SI unit of the conductivity is Siemens per meter. It is written here, Siemens per meter. 1 upon ohm is called as the Siemens. Now, What are the types of materials? Mainly, there are three types of material: conductors, insulator, and semiconductors. Conductors means the flow of current or flow of charges inside that material. That materials are called as a conductor. Example: iron, gold, silver, copper, aluminium, etc. Here, example is copper. We use a copper here. Copper wire. Insulator means electrons cannot be flowed through this wire. Electrons are not flowed through this plastic. So when we pass the current through the wire and when we touch this plastic, we cannot we cannot shock because the current are not going to this plastic. So glass, plastic, wood will be insulator. And semiconductors, third stage means it is not insulator or not, it is a conductor. It is an intermediate state between semiconductor and semiconductor. And semiconductor is an intermediate state between conductor and insulator. And semiconductors are used in this LED, etc. Or ICs, etc. So examples of this semiconductor are silicon, germany. So for this lecture, we will stop here. Next lecture, we study about the temperature dependence resistor. Also, we study about the definition of temperature coefficient resistance, resistor, etc. Thank you.